My name is Maimuna. I am studying first year MPCS. Subject is physics. Topic: Magnetostriction method. First, what is magnetostriction? A change in dimensions exhibited by ferromagnetic materials when subjected to a magnetic field. It is in Random House Dictionary. It is documented by James Joule in 1842. Curie temperature quite high. It is minus 750 degrees Celsius for 81 Fahrenheit. Effect will not dipole. Domain ordering returns without the need for poling after exceeding Curie temperature. Let's see about the magnetostriction method. Magnetostriction method is used to produce ultrasonic waves in the frequency range of 20 kHz to 100 kHz. In this method, we have to produce ultrasonic waves by using magnetostriction method. Principle: Magnetostriction method is a property of ferromagnetic material like iron, nickel, cobalt that causes these ferromagnetic materials to change their dimensions or shape during the process of magnetostriction. Magnetostriction material can convert magnetic energy into kinetic energy by doing mechanical vibration. When a ferromagnetic material is placed in a magnetic field parallel to its length, then a small expansion or contraction is occurred in its length. The change of length must be depends on strength of the magnetic field and strength nature of magnetic field. This is the principle involved in magnetostriction method. Now we can explain the production of ultrasonic waves by using this method from the following experiment. Let we see the experiment. See the diagram. There is a short nickel rod AB clamped at a center. The rod is permanently magnetized in begin by passing direct current in the coil, which is wrapped round. These are two other coils L1 and L2. It was wrapped round the rods as shown in this figure. The coil L2 is connected in plate circuit of a triode wall, while L1 coil is connected in the grid circuit. The frequency of the oscillating circuit is adjusted with the help of the variable condenser of variable C. Connected across the coil L2, the direct current in milliammeter reads the plate current. So, when the frequency of plate circuit is same as the natural frequency of rod, resonant vibrations are produced in surrounding medium. So the vibrations are maintained due to the coupling provided by the coil L1. When the resonant oscillate, the milliammeter records the maximum current. Let's see the working. When the battery is switched on, the resonant circuit L1C1 set up an alternating current O frequency, that is F is equal to 1 by 2 pi root over L1 C1. These current flowing round the coil L1 produce an alternating magnetic fields of frequency F along the length of the nickel rod. The rod starts vibrating due to magnetostrictive effect. The vibrations of the rod create ultrasonic waves. The longitudinal expansion and contraction of the rod produces an EM in the coil L2. The EMF is applied to the base of the transistor. Hence, the amplitude of high frequency of high oscillations in coil L1 is increased due to positive feedback. The developed alternating current frequency can be turned with the natural frequency of the rod by adjusting the capacitor. The condition for resonance: frequency of the oscillated circuit is equal to frequency of the vibrating rod. F is equal to 1 by 2 pi root over L1 C1 is equal to 1 by 2L root over E by rho, where L is the length of the rod, E is the Young's modulus of the rod, Rho is the density of the material of the rod. The resonance condition is indicated by the rise in the collector current shown in the milliammeter. What are the advantages? Magnetostriction oscillators are mechanically reused. The construction cost is very low. They are capable of producing large acoustical power with fairly good efficiency. Limitations: it can produce frequencies up to 3 MHz only. The frequency oscillation depends upon the temperature. Breadth: the resonance curve is large. It is due to vibrations of elastic constant of ferromagnetic material with the degree of magnetization. So we cannot get the constant or single frequency. Resonant vibrations are produced in the surrounding medium, that is, the sound waves of maximum amplitude are generated. In general, the frequency of sound waves must be in the range of greater than 20 kHz and up to 100 kHz. So these waves are called ultrasonic waves. Here, the frequency of LC circuit f is equal to 1 by 2 pi root over LC. Therefore, f is equal to 1 by 2 pi root over LC, where L is equal to conductor coil, C is variable capacitor. The velocity of ultrasonic waves is v is equal to root over y by e. This is about the magnetostriction method, the principle, working, and advantages and disadvantages. Thank you.